Okay, so let's solve the I equations. Okay, so I'm going to solve the first I. I'm going to try and solve all of them, and then yeah, so let's start. The first one is the Laplace equation, the transformation from rectangular to polar coordinates in r, theta, and this one. So basically, when you are given this question, make sure you focus on the questions that says asking you. Okay, focus on the question. So he said we should find what an expression for partial r in terms of what partial x, partial y, and partial z. And when you do that, partial what r will be equal to what partial x, partial r plus partial y plus partial what r plus what partial what z, partial what r. And so when you do that, you have to find what partial what r, partial x, partial what r. So you come to where x relates to what r and cos and phi, theta and phi. Then you differentiate the x with respect to y. Then you have this. You get sine theta cos phi. Then you find the same expression for what partial y, partial r. That will give you what sine theta sine phi. Then you find partial z, partial r. You come to here and you differentiate with respect to r. You get what cos theta. Then you put it inside your r. You put it inside. You put it back, and you should get what sine theta cos phi partial x plus sine theta sine phi partial y plus cos theta partial what z. Then you do the same thing for this one too. So there is also one thing that I wanted to show you guys around, like as a trick to this. Okay, so you realize if you are not able to like find these expressions over here, all you have to do is, the trick I want to show you is to focus on the question. So they say we should find an expression for partial r in terms of, so you just write partial r is equal to, in terms of what partial x plus partial what y plus partial what z. So what you have to do is just make sure that you divide all this by what, make sure that partial r is the denominator here. So we have partial r. Then all you have to do is to what, you send this to the top, you send partial x to the top, then you have partial x. This one will be partial y, sorry, you send this one to the top, you have partial y, then you have partial what z. So that's the same expression that you get over here. Okay, and then if they ask you for the theta one, so you make sure you divide through all by theta, and then you send the alternative one to the top, like to make them alternate. Then the same thing for this one too. When they ask you for phi on, you divide through by phi, then you send this one to the top. But they can also ask you to express partial x in terms of partial r, partial theta, partial what phi. In this case, what you do is you divide by this denominator, which is partial r. Then you send what partial r, x. I mean x. This, the denominator should be, you divide through by this one. Then you send the partial r to the top, partial theta to the top, then partial phi to the top. Okay, so that's how you get the expression. And when you are done, the only thing you need to do is to go and find what your partial. You need to go and find this one, the one that you can find. You know, you cannot find partial x. This is an operator. So the only thing you need to go and find is to go and find partial x, partial x, partial r, partial y, partial this. So we are done finding those things. And this is the two equations. The three equations you have is what 1, 2, and then the final one, which is what 3. And also the reason why this part doesn't have 3 terms is that the partial z, partial phi, there is no phi inside z. So when you differentiate with respect to phi, you should get what 0. That's why this one is 0, and then we have 2 terms over here.